Okay, I'm back. It's been a while. Been busy up here. I normally like to do a video a week, but yeah, just been distracted. A lot of stuff on my mind, lots to do. All right, let's jump into it. I've been wanting to do this for a long time, is to have battery backup power for a few things around the house. Number one reason why I got this is for my furnace. I have a gas-fired furnace. This is a small house, very well insulated. It's not the high efficiency furnace, and I wanted something I could plug into my inverter and run my furnace and refrigerators. Okay, and the second thing is for my radio communications. Anybody new to my channel knows, or if you're new to my channel, I am a ham radio operator and a CB radio operator. That old, good old Citizens Band radio operator, breaker. So radio communications. Okay, I was thinking to walk you through what I got here. When I got the lifetime battery, lithium iron phosphate, 12 volts, 230 amp hour. Okay, over here we have my Samlex power 2000 watt inverter, pure sine wave. That's very important. I have a pure sine wave, especially running my computer and all my sensitive electronics. Okay, anybody notice or wants to know, these come neutral and ground bonded. Okay, just like the electrical panel coming to my house, neutral and ground bonded on the plugs in the back. Okay, and then over here we have my 14.6 volt 40 amp battery charger specifically for the lithium iron phosphate. That's about all there is to it. I got my Anderson connectors, and I have my, did not do it yet, but I have a 125 amp fuse in line, fuse to put in there, a size for a 2-gauge wire at this length. So hopefully that'll be good enough. Hopefully it'll blow the fuse before melt wires, because that's what you want to protect is your wires. Okay. So, before we get into this, we're going to do a AC current draw test. And so, in order to do that, here's my little gizmo box. It's a little bit dangerous, but it's pretty cool. Keeps me on my toes. So, on the other end, this will plug into the wall. All right, I'm going to test the current draw, AC 120 volt current draw. This will plug into the wall. And anything I want to test, say my microwave or sweeper, which we're going to do, plug that in here, turn that device on, and then right here I have the neutral and line split or exposed. Because using clamp-on current meter like this, you do not want to clamp over the whole thing because you're going to get net zero because of the way the voltage and current between the two are going to be net zero, 180 degrees out of phase. So you need to separate them and then clamp on either one, or clamp around. I only have one hand here. Clamp around one of them. All right, then you will get your reading. So we're going to do that. Yeah, I'm going to plug my whole station into here, and I know what you're thinking. Oh my God, your whole station is going to blow this thing up. No, as you're going to see, we'll do some tests so you guys get a reference. Everything's so damn energy efficient. I'm going to be plugged into my 4K 42-inch TV, JBL soundbar, obviously the computer, Focusrite. What else we got going over here? Oh yeah, my Anomaly 7000 DLE, which will be powered by the Samlex 12-volt power supply, and my keyer box. Now, I know it's silly for this test. In an emergency, I would just plug 12 volts into plug the battery right into my Icon 7300 up there. But what fun would that be? So do it this way. I'm going from DC to AC and back there, then back down to DC. So normally we wouldn't do that, but for this test, we're going to have a little bit of fun. Remember, every time you transfer, of power, you're going to lose a little bit in that transfer. All right, so let's do some tests. We'll do a light bulb, a coffee maker, a microwave oven, and a vacuum cleaner. Okay, so just get a reference. All right, let's get on into it. Okay, here we are at this other bench. We're going to do a quick reference check so you can compare some different items to how much my station pulls. Okay, so right now we're plugged into my dangerous electrical gizmo device. That's plugged into the wall. Comes right on over here. And right now I have a coffee maker plugged in and a light bulb. Okay, this light bulb is, if you can see that. Zoom in there. It says 1,490 lumens or 72 watts. Okay, zoom back out. Check this out. Okay, we're going to turn the light bulb on. We call that 0.6 amps. Okay, 0.6 amps. Okay, turn the light bulb off. By the way, there's the law formula we'll be working with. Okay, let's get our power rating. 0.6 amps. 0.6 times 120 volts equals, and there it is, 72 amps. 72 watts. Okay, clear that. Now let's go do the coffee maker. Coffee makers, man. Pull a lot. Here we go, coffee maker on. What was that? 7.63. Okay, 7.63. Over here. 7.63, I think I said. Times 120. Sucker's pulling 915 watts. Just for a coffee maker. All right, let's go upstairs and for bleeps and giggles, let's do the microwave. All right, here we go. Okay, here we are at the microwave. Let's get this started. Wait, make sure I don't have a cat in there. I don't even have a cat. Let's get this started. $15.45 amps at 120 volts. Okay. All right, let's move into a vacuum cleaner. I have the light bulb in there. Watch, I'll shut the door. There we go. All right, do a vacuum cleaner. All right, we're gonna turn a vacuum cleaner on. It's small vacuum cleaner, Shark with the beater bar, the beater upper bar. Okay, I'm gonna turn this puppy on. Here we go. Beater bar on. Beater bar off. Load the motor. Turn off. All right, just getting some reference. All right, now let's go down and hook into my station. That was just the cool reference for you guys. Let's do it. Okay, got everything fired up. This is AC wall, AC power. I got my 42-inch 4K TV on. The JBL soundbar is turned up pretty loud here. Obviously, the computer, Focusrite, interface box, which uses pretty much nothing. The LS 7000 GLE is being powered by the Samlex 12-volt power supply. And right now, we are pulling just over 2 amps AC at 120 volts. Okay, I'm going to go ahead and key up here. I'm between channels here. I'm going to key a 7-watt carrier. That's about 7 watts right there, and about 27 watts peak envelope power. 27 watts peak envelope power. 2.89 amps AC at 120 volts. I saw that flash up around 2.96 amps AC. Okay, that's it. Not much. Not doing that much output power, just a little bit, but enough to communicate. All right, let me switch over. I'm gonna power everything down. Switch on over to DC power with the inverter. All right, so I'll be back. All right, guys, we're on 100% battery power right now. As you can see, I got the commercial AM band being received. I have the volume up. It's JBL soundbar is on. My entire station's on. The only thing it's not on is external, power amplifier. It's just in standby here, just receiving. 13.12 volts. And a little over almost 21 amps. All right, man, everything's political now, man. Woo. All right, let's go up to 11 meters. All right, we're now up on 11 meters here. I'm going ahead and, what am I going to key here? I'm going to turn this to a different frequency. Hold on here. There we go. I'm going to go ahead and key up. That's what I'll be keying. 8 watts, audio test, 1, 2, 3. I'm like 2 feet away from the microphone right now. It's picking that up. All right, there you go. That is receive only. Okay, go ahead and key up. 7 or 8 watt carrier. Audio 1, 2, 3, 4, 5. Audio test 1, 2, 3. That's peak envelope power. About 27 watts. Audio test. Battery power station test. Audio back out.
So well, I don't have to squeeze into pants. I don't have to worry about.
All right. So there you go. All right, I'm gonna wrap this up, and yeah, I keep hearing that beeping. It freaks me out. That's my clamp on meter. Let me know I had it on too long. All right, let's wrap this up. Okay, let's go ahead and wrap this up. I wrote all the numbers down, and let's see how close we are between the AC wattage and the, what we got for that DC when I converted everything. Okay, so during receive, the AC draw, I went back and watched video clips and did my best to write these numbers down because, you know, the multimeter, it floats around a little bit, so this is ballpark. So during receive, drawing AC, 2.1 amps at 120 volts. Now that 120 volts is the nominal. I forgot to measure it out of the wall, so let's stick with the nominal 120. 252 watts. Okay, and then when I key down, I'm going to put it in transmit, 2.96 amps. 120 volts at 355 watts. Okay, now DC, just receiving 2.8 amps times 13.12 volts, 273 watts. And then when I put the radio in the transmit, hit about 28.5 amps, and the voltage sag to 13.08, and we got power. I know it's using 373 watts. Now, if you take that 252 and subtract it to 273, what is that? Around 21 watts. So that's really, really close. And also take that 355, subtract it from 373, is we're at 18 watts. So real close, almost spot on. So there you go. Pretty cool stuff. Now I know I can live in the lap of ham radio luxury when the power's out, or CB radio luxury. Well, thanks for hanging out with me and my dangerous electrical gizmo device. Don't do this. You get electrocuted. You end up like me. All right, guys, I'm out of here. KP68, free and clear.